No, it's anniversary today, so what I did was I bought my wife candy that I pretended like I forgot she didn't like, so who gets to eat it? You. That'd be me, all right. So yay me. No. So anyway, so this is for the quiz next week. I just started my recording, so I need to go back. This is for, the answers for last night's. Talked about that. Okay. Let's go over some new stuff. A little bit of new, a little bit of old. A little bit left, a little bit right. Isn't that how the song goes? So, I'm all over the road. I thought we had country fans in here, and you didn't even pick that. You picked that up, did you? All right, good. Okay. Okay. So yesterday we learned how to simplify things. Today we're just going to throw in just a couple things that are little unique situations, and then we're going to work on some other skills. Okay? So if I'm simplifying something like this, the square root of negative 3 times the square root of negative 6. Okay? First thing you've got to do with something like this is realize that negative 3, there's going to be an I with that negative 3. There's going to be an I with that negative 6. And so you're going to have to do that first, and then you could simplify what's left. So I like to call it pulling out my eyes, because I got this talent. Did you hear the other class going, ooh, sick, or gross, or something like that? No. Okay, check this out. No. No, I'm just joking. Okay. Anyway. So you can imagine you took out an eye here and another eye here, so that I times I becomes an I squared. Okay? And then we have to remind ourselves what I squared is. Does anybody remember what I squared is? It is negative 1. Nice job. Okay? So why is I squared negative 1? Because negative 1, the square root of that is I. So what that tells us is that we must be able to take I times itself to get negative 1. Those are two very important facts. Okay? Now remember, we said that this is imaginary because, can I square a positive to get negative 1? No. A positive times a positive gives me a positive. Can I square a negative to get negative 1? No, because a negative times a negative gives me a positive. So this must be some number that's not positive, not negative. It's really neither. It's imaginary. But bottom line is I squared is negative 1. Okay? And so what we have is this. We have negative 1, and then we simplify our square root of 3 and square root of 6. There's two different ways you can do this. You can combine them to the square root of 18, and then just simplify. That's from yesterday. Okay? Or you could do something a little bit more elegant, and you could say, hey, there's a 3 there. Is there a 3 and 6? Yeah, it's made up of a 3 and a 2. So you guys that like to do your factor trees, you can see that there's 2 3s hanging out there. So where do those get to go? Outside. And my 2 can't go outside. It doesn't have any friends. So it's got to stay inside. I feel bad for the 2. Okay. So let's do another one here. If I said square root of negative 10 times the square root of negative negative, what the heck, 30. Okay. So we necessarily don't have to show everything, but if I took an I out of here and an I out of there, those would combine to give me what? I squared, which is negative 1. So pull your I's out first. Do 10 and 30 share any factors? What do they share? They share 5, but they also share 10. Okay? So we could either do this, again, one of two ways. We could see there's a 10 there. There's a 10 and a 3. Ooh! A pair of 10s. Ooh! That's going to come outside. I just kind of like making that sound. I could do that. If you don't like that, here's what you do. Negative square root of 300. What perfect square goes into 300? It's kind of big. 100. 100 is a perfect square. You can do it either way. But the bottom line is more practice with simplification and pull your I's out first. Okay? Okay, next one. We have 4 scenarios we've got to look at today. That's scenario 1. Scenario 2. X squared is equal to 4. What's x? X is 2? And 2, and there's another answer. Negative 2. So the way we write that is plus or minus 2. Granted, this doesn't have anything to do with I's, but I'm doing this so I will help you. I'm trying to help you see what you used to have to do when you're square rooting things. So whenever you see this, and in the past when you've gone, ooh, I need to square root both sides, you were told a couple years ago to always put a plus or minus on it. You're told to always put a plus or minus on it. Why? Because this tells us there's 2 answers. If we just put 2, we lost an answer. We killed the negative. So it's kind of like we're doing CPR and we brought it back to life by putting the plus or minus on there. So anytime you square root a variable, plus or minus on the next step. Okay, so what's that going to help us do? It's going to help us do this. X squared plus 9 equals 0. Okay? I'm going to dispel a common myth. I'll use my pink pen. Absolutely not. You cannot square root a plus. Don't think you can square root that and get that simplified. You can't. Why? Addition, subtraction, they're in a different family than square roots. They don't get along. So if I'm going to solve this, what do I have to do with this plus 9? Subtract it over. So I'm going to go x squared equals negative 9. So now what do I do to both sides? Square the root. So x equals what's the square root of negative 9? 3. I. And I need a plus or minus. Okay. Where did the I come from? I square rooted a negative. Where did the plus or minus come from? I square rooted an x squared. Okay? And if you look at it, for the last class, somebody says, there's no way that works, Rexroad. You're wrong. And I said, well, let's check it out. 3i, I took it, squared it, and I got negative 9. Negative 3i, I squared it, and I still got negative 9. They both work. They both work. Okay. Another one. Last one of this type. 6x squared plus 72 equals 0. Use your old solving skills. What do you think I should do? minus 72. Then divide by 6. So I'm going to go 6x squared equals negative 72. X squared equals negative 12. Square root. So x equals, don't forget, plus or minus. And then we can simplify square root of negative 12. So how does 12 break down? We're going to have a 4. We're going to have a negative 1 and a 3. Plus or minus what? Negative 2. 2i square root of 3. Okay. So the big thing there is isolating the x squared, and then you need the plus or minus. The rest is simplifying. Okay. Here we go. This next part, I think you find really easy. Multiplying. Multiply. 1 plus 3i times 2 minus 5i. Ooh, that kind of looks familiar, doesn't it? What are you tempted to do? Distribute. Yeah. Gee, I think that's why we probably did that a little bit. So distribute carefully. Keep track of your i's. And your I squareds, maybe. You done already? Are you done already? Okay. I want you to do that problem. Because you haven't done this before. Okay. Are you guys glad it's Friday?
Yeah.
I am. I'm going to try and spend some time, get a good time with my dogs this weekend. And my wife, of course. So we should have something like this so far. But look at this. I squared. What's I squared? Negative 1. So this whole term turns into positive 15. So we can go ahead and just cross that out and go positive 15. And now we can combine our like terms. Okay. 2 and 15. Hold on just a second. 17. I'm just joking. 17. 17 plus I. Yeah. Can you imagine that? Oh, God, I'm so bad with numbers. Okay. 17 plus I. So here's the thing. It's about time we need to have this conversation. You guys. Oh, my goodness. There's all different types of numbers you've dealt with in your whole life. We now, you know what, I probably should do this on the video. Okay? We are dealing with what is called complex numbers. I don't know if you need, I wouldn't necessarily write this down, but I want you to be aware of what's going on. A complex number is any, are you anxious to get out of my class, Cammie?
No. I'm sorry.
She just looked at the clock and was like,
No.
uh.
I know what time it was.
Yeah, we have like half an hour. We're okay. Okay? So, a complex number is something like 2 plus 3i. It's more involved than what we've dealt with before. Okay? Technically, a complex number is of the form a plus bi. Technically. We have a real part and we have an imaginary part. Now I'm going to blow your mind. Every single number you've worked with in your whole life is complex. Why? It's just the imaginary part was non-existent. Now we're telling you that it's kind of like we're in the Matrix or something. Yeah, all these numbers, they're really complex numbers. So the next time somebody asks you, hey, how old are you, or when's your birthday, or something like that, you can go, my birthday's on the 21st plus 0i. And you would technically be correct. Okay? So anyway, what happens is you've got all the numbers on the face of the planet. A plus bi. Some of them are the ones you've worked with before. They're all real. The rest of them have an imaginary part. Stuff like that. So we are now in a new realm within the realm of all the numbers that you've always been working with. Okay. So, but you know what's in, you know, and I don't disagree with you. Sometimes it's like, but believe it or not, a lot like this computer couldn't have been designed without complex numbers. Because it has capacitors, inductance, all this good stuff in there. And to understand how it all works together, electrical flow they use imaginary numbers to represent electrical impedance and capacitance and stuff like that. So it has its place, and it has made your life better. You just don't realize it. Okay? 2 more multiplication, and we'll get on to division. Here we go. Let's try this again. Negative 1 plus 6i times 2 plus 3i. Okay? I want you to do that, and I want you to compare your answer with your neighbor's, please. I'm going to have you do 2 problems. I want you to do this one. And then I want you to do this one. And both of them, you can even get up, move around, compare your answer with neighbors, somewhere across the room. I'm going to go for a little walk. You guys can do this. You don't need me. I'll be right back. It's Friday. All right. How's it going? Good. Hey. You guys gonna lock me out, were you? Did you get them?
That's 2 points. Yeah.
What'd you get on the first one? Negative 20 plus what? 9i. Perfect. Nice job. Okay? So you took a complex number times a complex number, and you got another complex number. Okay? Woohoo! What'd you get for the second one? 13. Plus no I. Okay, well that's interesting. Okay. So here we go. Just in case somebody struggle with this, I want to show. I actually just went to the lounge to see if they had any food. Yeah, I am. So this is minus 18. No, I just want to do something different. Yeah.
My turn. My turn. All of us.
$13. Okay. So we just have one skill left to do. What is that? Division. Division. There's a simple division and there's a more difficult division. Nope. We have other things to do on Monday. 3 divided by 2i. Okay. So this is when you're dividing something by an imaginary that doesn't have a real part. This is what's called just a simple imaginary or a pure imaginary on the bottom. Okay? So this one is very easy to deal with. Mathematicians, we don't like eyes on our bottoms. Okay? Unless it's my wife. She can look all she wants. But we don't like eye on the bottom. Okay? So anyway, so what you're going to do is you're going to multiply top and bottom by I. You're going to multiply top and bottom by I. Okay? So we get on the top 3i. What do we get on the bottom? 2i squared. Which, what's 2i squared? Negative 2. So then we can just rewrite that with a negative up top or on the bottom or out front, whatever. So do we have any i's on the bottom anymore?
No.
Nope. That's good. Okay. So that wasn't so bad, was it?
For now.
Just multiply the top and bottom by I.
I -1.
Okay. Question. Question. What did I really multiply by? Oh, hold on. What is I divided by I? 1. I multiplied by 1. So the reason why I'm saying that is I'm multiplying by 1, so did it change my value of the expression?
No.
No. It just modified it. It morphed it into something that was more usable for me. Okay? Gee. I wonder why we're doing this one over here. This is weird. 3 over 1 plus I. Well, I want to show you, I suppose I probably should put this in the video. Multiplying top and bottom by I won't work. Hopefully you see it's a different scenario. If I would multiply by I with this color pen, I get 3i over I plus I squared, which is 3i over I minus 1. Did that do its job? No, I still have i's on the bottom, right? Okay. So, gee, does anybody have an idea of what I might be able to multiply through by that would get rid of my I altogether? Look at the example up top. So in this case, because if we look up top, look at it. We have 3 plus 2i times 3 minus 2i, and the opposite. It's what's actually called a complex conjugate. The complex conjugate is where your imaginary part's different. It's just the opposite. So what should I multiply top and bottom here by? 1 minus I. So I'm going to go ahead and take this down here. I'm going to go 3 over 1 plus I, and I'm going to multiply by 1 minus I. And again, I'm really multiplying by 1, so it's not changing it. So on the top, I get 3 minus 3i, and on the bottom, 1 minus I plus I minus I squared. Okay, I'll let you guys get caught up. Okay, let's simplify the bottom. My i's cancel. The negative I squared turns into what? Negative 1 plus 1. So I get 2 on the bottom. Okay, but does that look like my traditional complex number? No, I've got like division in there. So this part's nice. We just go ahead and say my real part is 3 divided by 2. My imaginary part is negative 3 divided by 2 times I. And that's our final answer. So what you do in that situation, when it's more complex, when it's tougher, you multiply top and bottom by the complex conjugate. And then it'll get the I off the bottom. Okay? So here we go. What do I want to do? We have 2 things. Top one's due Monday. There's only 10 problems. The bottom one is a review assignment that is due on Tuesday. Okay? So I would probably recommend doing a portion of that before Monday, so you don't get piled on for a Monday night, because we are going to do something. We're going to do work. No, we're not going to do worksheets on Monday. Tuesday, Thursday, and Friday are all worksheets. So anyway, Cammie, you got 20 minutes. You're not allowed to leave for 20 minutes, so I'm sorry to give you that bad news, but it wasn't just a look. It was like, and then she looked, and she turned, she goes, oh. No, I know.